Auckland City Hospital Extension is a project that sought to upgrade existing medical services for both medical professionals and the broader public. This entailed the construction of a new building that would provide a higher standard of medical care and would allow equipment to be housed inside for future advancements. Grafton Hospital's facilities were developed in the process, while also maintaining an individual identity for both the existing Adults Hospital and the Starship Children's Hospital. The old nursing home being privately owned was a huge constraint in the extension process. Among other factors, the site provided a series of challenges.
So noise is a big issue, dust is a big issue, and just traffic manoeuvring. So how do you build a thing in the middle of the main car park and keep the emergency department running?
As well as contending with the site's existing surroundings, the design had to become a place of refuge for the Auckland public.
And so this is like a national disaster centre. So if there's a major event either in the whole of New Zealand or just Auckland, so earthquake, volcano, this building needs to remain operational.
Foundations protect the hospital through a technique called base isolation. Made of lead, rubber and steel, they separate the force of the earthquake from the building by dissipating the energy through the foundations before it damages the upper structure.
Now steel versus concrete, basic system. And then a moment frame, which is rigid construction, all the bits like beams and posts, versus the other one was like a eccentrically braced system, which is the one we ended up with. And the third one is big shear walls which run right through the building. And if you did one of the big shear walls running through the building, it actually has an impact on your future planning. So it restricts flexibility in the future. So you want to try and avoid that option.
The main structure employs a generic system of concrete slabs supported by post frames that disperse loads to the edges through lateral beams, which in turn creates a flexible floor plan for future shifts in spatial requirements.
In a building like this, if there was an earthquake, in between them, where the two elements come up, there's a bit in the middle, and that's called a fusible link. And so if the structure moves, that bit is a bit buckles, so it doesn't, they don't touch. So the forces don't quite move through, so that sort of buckles and bends. And you can then replace one of those K braces if you need to. So you can store, and so with these ones you could actually get access to it. But there are some on the long north and south facade where they're buried in the facade.
The EBF, or essentially braced frames, are exposed on the west and east facades, creating a sense of security. However, on the north and south elevations, a complex facade system was chosen for the purpose of aesthetics. This perfect blend of structural support and architectural embellishment creates an intriguing building canvas, both externally and internally, right through to the central atrium space.
With the facade, we wanted to get more articulation in the facade, and to move one floor 100 millimetres was adding near enough $1 million to the budget. So that scale, so we worked with thinness, and we sort of said, right, okay, we can't work with getting articulated and modulating the building, so we pushed hard to sort of work in the very thin slivers of planes. So we worked with, even from the outside, just these skins which are just sliced all the way through. Engineers on the building too. So while we would design it, we had to maintain certain pressures, air moving out of the building and into the building, had to maintain certain pressures. So it's quite a sophisticated facade. So we had facade engineers looking at all those details, because you get, it's quite a high wind zone. And you've got to get those details right. And then we built up, in Australia, we built up some test rigs to look at the system, because it's like a pressure equalised system in the middle, and they're built as prefabricated units and brought onto site. And the interesting thing with that is like when we built a test rig, and they kind of spray water all over it and sort of see how it's actually performing. The first run, there's quite a lot of water getting through, and there's holes drilled in the facade to allow it to drain. And the answer to solve the problem is actually drill more holes, so to make it more permeable, and that actually, because you're dealing with trying to equalise the pressure between the outer skin and the inner skin.
Another building element that contributes to this water management system is the roof.
Yeah, and we didn't. I mean, we looked at siphonics drainage, but we just got almost traditional downpipe.
The roofing provides the essential role of distributing water into the internalised guttering through means of downpipes that are placed at every second and third column, carrying the collected water to ground level.
We never really, I don't think, invented anything completely new in the building. I mean, because there's a reluctance from the client's point of view to, they often have an attitude, well, we don't want anything that has never been tested or tried before. We don't want to be the guinea pigs, because if we get it wrong here, it could be a big mistake. I do think like simple things like just the floor surfacing, was a big step, because normal hospitals and you went into, they were always just sterile and institutional and kind of like lacked any sense of quality. We just, by using colour and some changing surface materials, made a significant difference. Because orientation's challenging, in these environments, because it's you walk into the building and you're lost so easy.
We asked staff what they thought of the colour signage.
I never knew that.
I've seen better somewhere in other places. Yeah. I've seen hospitals where you actually follow lines on the floor, which is quite nice. You just look at the floor and you refer to a colour for a department, and you follow the line on the floor, which is great. So now I haven't seen anything here, or I haven't actually understood it. That's great. But the first minute you don't know where to go, really. So finding the way around is that easy.
The signage is really poor. People get lost and they can't find their way around. It was explained to me that it was an aesthetic decision to have all the signage flat against the walls, but because it's such a huge building, I think the patients come in and they see this giant corridor that goes on forever, and there's no signage coming out to tell them which direction to go.
It is apparent that the application of colours does not assist the medical staff or the public in terms of navigation. What was considered carefully, nevertheless, was staff's mode of operation.
There's things like we looked at a study which was actually following a nurse around on her drug runs, and by moving the main drug storage space, it might have been 15 metres closer towards the central staff station, they were saving something like 800 metres in a shift of travel time, the amount of time they do it. So those are things that make a difference. So we've done well to achieve, I think, quite a happy space in a place. So that does work, and that just changed the culture of how people worked in that environment previously. So it certainly has made a big difference.
The extension certainly prevails in functional performance, but this is short-lived due to other design shortcomings.
On level 4, at the main entrance, you've got the glass doors, right? And then you've got all the seating just inside for people to sit and wait. Okay? So what you have is every time the doors open, it's freezing. The wind goes whoosh in, because I think outside where the cars come and go, it's like a wind tunnel. And so it's ridiculous. You sit there, it's freezing cold every time the doors open, and that's where the public is supposed to sit and wait. It's ridiculous. Especially the main entrance, it's just not normal. I mean, it's a wind tunnel. First of all, it's just crazy that the wind that you have. So you don't have a good first impression.
It is evident that through strict client specifications and a tight budget, problems are bound to arise.
Contractors are always tough, because what they do is, this was referred to as a GMP, which is guaranteed maximum price. In the end, there were some mistakes that architecturally are wrong, and they began functioning. That's fine. It's fit for purpose. We're not changing it. And there's these little things all over the place you find as you go. But So then you have the debate where the contractor say, well, we're taking that to the client reference group, and the client group is saying, well, yeah, okay, there's nothing wrong with it functionally.
What the GMP does reflect is the penetration of light into the hospital for the benefit of both patients and staff.
Well, I mean, from the surgeon's point of view, I mean, they're saying they're in there for 8 hours, even more a day, and they're in there full on, and yes, they're operating, but for them to have a sense of their external environment is quite important.
Key has an interesting opinion on this matter.
There is one thing I think is really silly though. The hall coming round to room 4 that faces north with the windows, big huge picture windows, in the hallway facing north. Well, why would you do that? A hallway facing north with the big picture windows. There should be a staff room or something there, or do you know what I mean? It's not orientated.
It shouldn't be a corridor.
It should not be a corridor. Or it could have been the theatre actually had windows looking in. You know, we could have blinds that open and close to adjust the light. But that is really silly. Architecturally, that is completely wrong.
The central atrium that is naturally lit by a curtain wall ceiling does perform efficiently and accomplishes a natural, comfortable space.
The central atrium is all naturally ventilated. That space, we're just pumping air into it, so we're not fully air conditioning the central spaces. And you only create a air-conditioned or semi-air conditioned environment over the bridges. So it's kind of like controlled. All the landscape we wanted through there, we really were trying to get light shafts going deep and down into the building. So we did a lot of light study analysis on that central space to ensure we can get lux levels down to the bottom, so it was actually going to be a place that's not just a dumb light well. It's actually a
foster, yeah.
And so we managed to get some vegetation grown in there, and the big, huge palm trees, which is a good thing.
The curtain wall has been designed to minimise heat loss that a mass of glass would normally cause for applying double glazing and having a maximised air gap. This walling type provides the atrium users with the distinct experience of being outside, which gives the impression of there being no roof. The natural gardens further amplify this illusion, providing an enjoyable escape while ensuring medical care.
Just thinking that in the atrium you actually see the structure. And somehow, even if nobody knows about architecture and safety rules and resistance, it gives you a sensation of being strong. So I think it's a good idea actually.
It's comforting.
Yeah, it is.
I really like the atrium.
Yeah.
It's nice to have natural sunlight, to be able to see what the weather's doing.
Yeah.
Especially given that this department's 1 floor underground, you can feel a little bit trapped in a hole, so it's nice to be able to walk out and have a feeling of space.
People love the atrium.
Public building extension has gained architectural merit, which has set a new standard for future medical buildings in the Southern Hemisphere.
This has been studied as being a primary contemporary hospital designed by anybody since after this building was done throughout Australia.
So you believe it definitely lives up to expectations?
Yeah, no, certainly. It works incredibly well. What I like about this building and the way it works for me was, I do very much remember going to the old hospital and just listening to it, and listening to the noises and the sounds of people talking. In the new building, same thing, I really noticed that it was a happy sound. So the staff are jovial, talkative, happy. The patients seem happy. And there's just quite a nice background noise, and you're going to get a sense, well, that might be a way of defining that it's working well.
The design of the Auckland City Hospital attempted to challenge the stereotypical hospital condition. The architects sought to create a sense of a hotel rather than a hospital, and in many respects this level of quality has been achieved. Despite minor criticisms, the hospital still accomplishes its primary principles while also becoming an example of architecture that stands beyond the stereotypical building standard. The technology utilised is best described by Ewan McKellar. It was evolution, not revolution.